The squeeze theorem explained in 2 minutes. Say we have 3 functions, f, g, and h, such that near a certain x value a, g is enclosed below by f and above by h. The squeeze theorem states that if the limit as x approaches a of the top function and bottom function is equal to some L, then the middle function must have the same limit. This is very intuitive to understand because g is sandwiched between the two functions, pinched between the two functions. So it's only natural that it's going to have the same tendency as x approaches a. And by the way, this is the reason that the squeeze theorem is sometimes referred to as the sandwich theorem or the pinching theorem. And by the way, we only care about the small vicinity near A, the small neighborhood around A. So if G is above H, for example, somewhere else, that doesn't matter. Let's now take a look at a classic example. Say we want to evaluate the limit as x approaches 0 of x squared sine 1 over x. This is a very tricky one because if we try direct substitution, we get 0 times sine 1 over 0, which is like sine infinity. And this is problematic because sine oscillates between -1 and 1, and it doesn't have a clear tendency. But the fact that the sine of anything is bounded between -1 and 1 allows us to use the squeeze theorem here. If we multiply everything by x squared, then our function is bounded between -x squared and +x squared. The bottom and top functions both have a limit of 0 as x approaches 0. So the limit of the middle function must be 0 by the sandwich theorem.